All right. When we talked about rotating a region about an axis with the disc washer method, our rectangles were, remember this, perpendicular. Okay. We are now going to talk about a method today where we are going to rotate regions about an axis, but instead of making discs or washers, we are going to be making shells. Not like seashells, like cylindrical shells. So did you ever have like those cups that you could like cup, and there's a cup that goes inside the cup, okay? Or those little, are they like Russian dolls? The nesting dolls were like that, but with cylinders. Nesting cylinders. Okay. Yes, there's going to be an infinite number of cylindrical shells. I'll show you. I'll show you. Now, since we use perpendicular rectangles to create our disc washers, we are going to use parallel or parashell rectangles to make these revolutions. Okay. When we use the shell method, we're going to have rectangles that are parallel to the axis of rotation. So we're going to take a rectangle and we're going to rotate it around. And we have like this cylindrical shell. So like think of, aren't there those like Easter candies that it's like a chocolate shell, but then there's like marshmallow inside? Okay. So like, I just want you to think of this as like a shell. What? Kind of, except we're just like yeah. Yeah. A pistachio. Yeah. Okay. So maybe it would help if I gave you a visual. Okay. So notice how I have a region and I'm building this three-dimensional solid by making shell, 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 shell. You see it? So what are we going to do? We're going to find the volume of those shells and then add them together using an integral. Wow. Okay. All right, so let's talk about this cylindrical shell. Let's imagine that I cut it and I lay it out. What is it? But it's three-dimensional. Okay. So if this is the height, then this is the height. What is this length? Yes. Okay. So the volume of this rectangular prism is length times width, so 2 pi r times height times, just say T for thickness, okay, or width, or depth, whatever. Okay. So this is what's happening. The height of our cylinders our top function minus bottom function. The height of our cylinders is just going to be top minus bottom. And then X, so this is like the height. I would love to go back. And then this is going to be the radius. How far away is any given rectangle from the x-axis? Well, that is X away. This rectangle is X away, X away. Okay. Don't draw it. Somebody wanted me to go back to this diagram.
Yeah,
Hold on, I'll go back. Often my speed is maybe a little bit faster than Kylie would prefer, and I need to be better at slowing down. This is what you need. This is what's important today. Okay, the volume of our cylindrical shell is 2 pi RH width. Okay, our radius, how far are we from the x-axis? Excuse me, y-axis, we're X away. Radius, how tall is our cylindrical shell? Oh, top function minus bottom function. And then our thickness is dx. So we have an infinite number of infinitely thin cylindrical shells, like those nesting dolls that just stack together to make a solid. Okay. What? What are you talking about, turtles?
Shells. Yeah, shells also turtles. No, I think I think turtles do have shells.
Turtles have shells, yes.
Oh,
So turtles equal math. Why are you drawing on me?
Okay, so why am I teaching you another method? Okay. Yeah, for fun. So sometimes it is not convenient to go in terms of X versus Y, okay, depending on the problem, okay? I picked out some pretty nice problems for your quiz, knowing that the disc and washer method would be awesome, okay? However, do you remember like if we had like one of these guys, right? And if we were trying to go in terms of Y, that would, excuse me, in terms of Y, that would stink because our left function changes partway through. So now this gives us another option. We are not like locked into one method. We have a choice, okay? Now, what we're gonna do is we're gonna practice the shell method for our volumes of revolution. And then on Thursday, your quiz is going to be disc washer and shell method, okay? Yes, Matthew. Okay. Is this visual, is this helping you? Do you see like our nesting cylinders? Do we see our nesting cylinders? So like, okay, this is our region right here, okay? So by drawing dx rectangles, we're doing the shell method, okay? Now, if I drew dy rectangles, we could do the disc washer method, but we would have to do 2 different integrals because the function on the left changes. So right minus left, we would have to do 2 different integrals. Do you want to do 2 different integrals? Never, yuck, no. Okay. So here we go. So that picture that I was showing you, this is how we got it. So y equals 1/2 x and y equals x minus 1, the quantity squared. Write it down. Let's get a picture drawn. Are you okay? Do you need a new pencil? Definitely, did not give myself enough room. So we have this region right here that we are rotating about the y-axis, right? My parabola looks really silly. Okay, so don't draw this with me here. But before today, our only option would have been to draw perpendicular rectangles with dy. And notice how the left portion of my rectangle would sit on the red, but here it would sit on the blue. So we would have to do this in two different integrals. Well, nobody wants that, which is why I'm teaching you the shell method. So we can draw in parashell, okay, parallel rectangles to rotate around the y-axis. Okay, so when we set this up, we have 2 pi integral of radius times height times thickness. Okay. Well, what's our radius? Our radius is always going to be the distance that our rectangle is from the axis. Well, how far would any of these rectangles be from the y-axis? They would be x away. So that's our radius. Times the height. Well, how tall are these rectangles? Well, all we have to do is top minus bottom. Our top function is 0.5x minus our bottom function, x minus 1, the quantity squared. I know we have limits of integrations missing, limits of integration missing. I know they're not there. However, until we get there, this setup, do you have questions about it? Okay, this is a good question. For today, it's going to be x. Tomorrow, we're going to practice rotating around like x equals -2, and then ours will change. Okay, for today, we're just going to worry about the x-axis or pretty soon, or y-axis or pretty soon the x-axis. We are not. Okay, does that make you happy? Okay, me too. All right, so now let's talk about our limits of integration. I need to know where these two bad boys intersect. 2? Okay, so the top one is 2. We don't know the other one. Okay, so remember, we can do algebra. It's a thing. We can take 1/2 x and set it equal to x minus 1, the quantity squared. So when we set this equal to 0, we have x squared minus 3/2 x. Nope. Let's try that again. It'd be 5/2, wouldn't it? Okay, well, we already know that 2 is an intersection point. So what needs to go here that multiplies, that'll multiply to get 1? Okay. And we have negative 2x minus 1/2 x. That'll be good, right? So here we go, 1/2. Okay. Math 9, you're welcome. Math 9. What I would do is I would put the 2 integral, blah, 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 blah. Then later we can worry about the pi. I don't want you to forget about the 2 though. So I would put the 2 in front of your integral when you do math 9, so you don't forget about it. What? Yeah, you need the x. Yep. Everything but the pi. Tomorrow's morning run. Oh, we were like shrewd. That's like the Tuesday before. Action day. Well, it is. That's what it's called negative. Not basically. Because you eat all the things that you're gonna maybe give up for. Okay, Aaron, what'd you get? 45 over 32? Do we agree with Aaron? Weird. Weird number, but we'll go with it. Okay. Should we try another one? Aren't you glad you didn't have to do 2 integrals? Honestly, I really like the shell method. I think it's quite fabulous. All right, here we go. Shells and cheese. Did you say math and cheese? You said math and cheese. Okay, here we go. We have y equals 0, y equals sine of x, 0 to pi, revolved around the y-axis. Bless you. What's true about 0 and pi in terms of our function, sine of x? They're zeros, yes. What? I would not call this a semicircle, but it's not. But it's not. Okay. Now, I was gonna say something now. Take a walk. concentrate, because when you're concentrating, you're good. Okay, now, don't draw this, but if I were to draw a perpendicular rectangle, we would not be able to do this problem. No. Because I cannot rewrite y equals the sine of x as, yeah, it's just not, it's not gonna work. Okay, our only option right now is the shell method. I remember what I was gonna say. Imagine this being rotated around. It's going to look like a butt cake. Can you imagine it? Bunt cake. That doesn't surprise me. Okay, so we're gonna create shells with this bunt cake. Is that better? Okay, so we have 2 pi the integral. Hey, we know our limits of integration. They gave them to us, 0 to pi, of our radius, which is x, times the height. Top minus bottom is just going to be sine of x. Now, we do not have the tools in our toolbox to integrate x sine of x by hand, but those of you who take Calculus 2 next year, or Calc BC juniors, you will learn how to integrate this by hand. One of the best methods ever. But for now, we'll use Math Night. It's seriously the best. Integration by parts. It's 2 pi squared. What? Okay, yeah. 2 pi squared, which is approximately 19 point. We don't have school on Pi Day. No. It's the first Monday of spring break.
We can have an early. We'll do the Friday before and we'll all bring pies.
I'll bring, I'll never see that. We go see this.
I'll think about it. Okay.
I'm gonna have to hit that. What pie should I make?
Apples.
Okay. Are we okay with the setup of this problem? What is your question?
I don't know what I do.
I would love to. You're in degree
Oh.
Yep. Okay, what's different about this problem? We're gonna rotate about the x-axis, so write it down, let's draw the picture, it's gonna be great.
They made it.
Oh. Okay, I need a practice.
Yeah, it's good.
I'll have to show you the pie that I made.
Oh, is it done with the pie? I don't know, I've never seen it. I love pie, especially when my mom makes chicken pot pie. It's so much better than like.
These pies are entirely new pies. So, yes.
It's like
It's
soup.
pie in the name.
If you have it ever, it's so contracted.
Why can't a pie not be? Because I said no. Yeah, why is pie dessert?
I made the first pie back in 1896.
This is true.
All right, here we go. Here's the pie that I made on Pi Day in 2019. It actually wasn't that bad. I have like cookie cutters. I have
There's somewhere in your storage room or there's like a cabinet above.
I have letters and numbers and shapes. I have like a big bucket of like 100. All right, here we go. So we have, I'm so sorry that we have been disrupted here. That was my fault. I don't know if this is my favorite region here, but. All right, so we're gonna rotate about the x-axis time. Now, obviously, we could do the disc washer method without a problem, but I wanna show you how we would do the shell method with this region, okay? Now, if we're gonna do the shell method, we want parallel, parashell, rectangles. Oh, so we're gonna do this in terms of y. So we have 2 pi the integral. Our radius this time, instead of being x, is going to be y. And our height, instead of top minus bottom, is going to be
Right minus left.
right minus left. So our right function is going to be the square root of y, and our left function is going to be y over 4. Do you notice I changed those to y's because I had dy? Not everybody's been doing that. Okay, we're gonna totally do this one by hand though. Okay, what are our limits of integration? Obviously 0, but what's this coordinate right here? 4, comma, 16. Okay, now the shell method definitely gives us a better opportunity to do these by hand because there's nothing like squared, right? So we have 2 pi integral from 0 to 16 of y to the 3/2 minus y squared over 4. This is going to be so exciting, people. Y to the 3/2, antiderivative. Minus y squared over 4's antiderivative would be y cubed over 12. Okay, so we integrated it by hand, but we still totally need our calculator. Well, let's see. So we have 2/5, 16 to the 5/2 minus 16 cubed over 12 minus 0. Okay, so let's talk about 16 to the 5/2. We square root 16 and then put it to the 5th power. What's the square root of 16? 4 to the 5th power? Yeah. What's 16 cubed?
Oh, it's 735. I don't even know 16 cubes.
No, it is 4.
Oh, 16 to 16 is like.
It's up there.
4096.
Yeah.
Oh,
Well, because it would be 4 to the 6th. So 4 is 2 squared. For, okay, so now you need your calculator because I'm what is it?
I'm so for the other.
You did.
You say it one more time.
Is that right?
Just 2048 was the greatest game of all time. And we actually won. I don't think I was a 2. No, 64. If you never just passed like 600.
Okay, there that is. All right, so in your homework, it's gonna ask you to set up the shell method. Even if it's more inconvenient, we need to practice setting up the shell method. Okay, eventually we're gonna get to choose. Would you have chosen the shell method here? I don't know. We really like going in terms of X. I feel like if you can say in terms of X, that's gonna be your choice. But we'll kind of see how things play out. Okay. Like I said, now that we're kind of at the tail end of this, Thursday's quiz is going to be only volumes of revolution. So dishwasher, shell method. There's going to be problems where I say, use the disk method, use the shell method. Or I'll say, integrate with respect to X, integrate with respect to Y. You have to figure out which one to use. Or I'll leave it open and you choose. Okay, so you're going to have options, or you're gonna have problems like that as we lead up to Thursday. Okay, so you need to be comfortable